All right, ladies and gentlemen, in this video, our objective is to utilize the properties of a rectangle and some algebraic connections in order to solve for a missing segment or even a full diagonal's length. And this is important because the rectangle diagonals theorem tells us that a parallelogram is a rectangle if and only if, there's our biconditional statement again, right? If and only if the diagonals are congruent to one another. So let's keep in mind here, yes, it's a parallelogram, so we already know that the diagonals are bisecting each other. But we have now, in addition, is the fact that the diagonals are in fact congruent to one another. So how would we maybe see this in some application? Well, it says, in the following rectangle MNOP, Pn is 7x minus 8. Well, Pn is a whole diagonal, and it says that MO is 4x plus 10, also a whole diagonal. What's the length of Pn? Well, ladies and gentlemen, we just found out that Pn equals MO. So that means that 7x minus 8 equals 4x plus 10 after we substitute. If I subtract 4x, I get 3x minus 8 equals 10. If I add 8, I get 3x equals 18. And then after I divide by 3, I get that x equals 6. But be careful, guys. It wants to know what the length of Pn was. So make sure that we substitute it right back in to the value of Pn. So we have that 7 times 6 minus 8 will give us our value. And 7 times 6 is 42, and minus 8 is 34 for the value of Pn. So there is a little bit use of how we can apply the characteristics of rectangles in some applications.